going to be working the solutions to 2-1, which is the section on the derivative and rates of change. So we'll start out with number 1. All right, we have find the slope of the tangent line to the parabola y equals 4x minus x squared at the point 1, 3. And it says for part 1, we want to use definition 1. Now definition 1 appears in the book. They're referring to definition 1, which is on page 75, which is that the slope of the tangent line, I'm going to put m tan, is equal to the limit as x approaches a of f of x minus f of a over x minus a. All right, we'll start with that and then we'll do the other one. So whenever we're looking at our parabola over here, we first are going to replace the y with f of x. This is going to be our function, f of x. And here we're going to identify what a is. A is the x value that we are going to be approaching, and here you can see the x coordinate of this point is 1. And of course, this is what you would get if you plugged 1 in. So if you plug 1 in, it should spit out 3, which it does. So that's f of a, or in this case, f of 1. All right, so let's go back to this. This should be equal to the limit. I'm going to replace all my a's with 1. Here, f of x doesn't change, minus f of 1 over x minus 1. And this is equal to the limit as x approaches 1 of f of x. Let's actually replace f of x with what it is. So what is f of x? It's this function right here, 4x minus x squared, minus f of 1, but we already know that f of 1 is 3. So this is 3 over x minus 1. And I'll just clean that up a little bit. That's equal to the limit as x approaches 1. Let's see, I can do 4. Oh, no, I can't do anything there. I'll just put it in descending order. I don't have to do this, but I will, over x minus 1. All right, now we can check real quick. If we were to let x go to 1 right now, we would get negative, 1 squared is 1, so we get negative 1, then plus 4, and then minus 3 over 1 minus 1. We would get a form of 0 over 0, which is bad. So we need to do some algebra now. So this is equal to the limit as x approaches 1. All right, I'm going to need to try and do some factoring up top. So depending on how comfortable you are with this, let me try this. Negative x and x. Let's see, negative 3 and positive 1. Let's try that. Negative x squared, good. Minus and minus would be plus 3x, and then another x in here, so that would give us 4 x's. Then 1 times negative 3 would give us negative 3. So that's the correct factorization. On the bottom, I have x minus 1. Now we're almost to the point where we can cancel, except that we notice that these two are off by a sign. So what I will do is factor negative out, and that would change that to positive, and that would change that to negative. That's really a negative 1, but I'll just put negative there. And then these factors cancel completely, and we're left with limit as x approaches 1 of just what was there, x minus 3. And as we let x go to 1 here, just direct substitute, we get negative 2. Now I want to make sure, were they asking for the slope or the... Yeah, the slope. Okay, so for part A, this is all part A. We're asked for the slope of the tangent line, so the slope should be negative 2. Now for part 2, they want us to use equation 2, which is a different formulation of the same thing. We should get the same answer. So for part 2, we're going to use equation 2, and that says that the slope of the tangent line is the limit as h goes to 0 of f of x plus h minus f of x all over h. All right, so let's see what happens when we use this formula instead. Now we still are going to have to figure out, I'm sorry, I put x instead of a there, I believe. Hold on. Yeah, f of a plus h. I'm thinking I'm already a section ahead, sorry. There we go. All right, so all we're going to do now is remember a is 1, so I'm going to go limit h goes to 0, f of 1 plus h minus f of 1 all over h. Now we do limit as h goes to 0. All right, 1 plus h gets plugged into the function f. So I replace this with 1 plus h and that with 1 plus h. So I have 4 times 1 plus h minus 1 plus h, that quantity squared. That's this. Minus f of 1, we already know f of 1 is 3, all over h. And you could check for yourself if you let h go to 0 right now, if that goes away and that goes away, we will get 0 over 0. So at this point, what I will do is I will expand out the numerator. I'm going to just multiply this all out. 4 gets passed through, and then I expand this. Just make sure you remember that when you expand this, whatever it is, you're then going to distribute a negative to each one of those. So I should get 4 plus 4h. That's this. Then minus, I'll go ahead and expand it all first, and then I'll say minus 3. And all of this over h. So if you do 1 plus h times 1 plus h, you get 1 plus 2h plus h squared. But then we'll have to pass the negative through. So we get limit h goes to 0, 4 plus 4h minus 1 minus 2h minus h squared minus 3 all over h. And good things are about to happen because I have 4 minus 1 minus 3, that's 0, it's gone completely. I can put these two together. So I should be at the point where I have limit as h goes to 0. 4h take away 2h is 2h. I still have minus h squared and then all over h. And the whole goal of this is to try and get this h to go away because that's what's causing the division by 0. And we can see that we can do that by factoring an h out on top. You know what? Hold on a second. Yeah, all right, so that, and then minus, pull out an h, sorry, minus h all over h, and then these h's cancel, and we get just this. So limit h goes to 0, and then 2 minus h, and when h goes to 0, you just get 2. Now, I thought we got negative 2 just a second ago. I don't know, my brain is thinking that we got negative 2 a second ago. I guess I'll have to go back and look in the video, but these should be the same answer. Hopefully in the last one we got 2. And they match up, so that's it. We're good. So that's part A. Part B is find the equation of the tangent line from part A. So now what we need to do is use this information, part B, to find the equation of the tangent line. Remember, all we have found so far in both, in part A 1 and 2, both of them, 2 different ways of finding the same thing, we found that the slope of the tangent line was equal to 2. But we need the equation of the tangent line. So remembering back from college algebra that if you have a point and the slope of a line, it's called the point slope formula, we can use this y minus y1 equals m times x minus x1 to find the equation of the line through that point with this slope. We know the slope of our line, right, is 2. And we know a point on the line, x1, y1, comes from this right here. This is x1, this is y1. So I can just rewrite this as y, take away y1 is 3 equals the slope, which is 2 times x minus x1, but x1 here is 1. And that is the equation of the line. Now, we always like to solve for y to get in what's called its slope-intercept form. So first thing I'll do is distribute the 2 through, 2x minus 2. Then I'll add 3 to both sides. Y is 2x plus 1. All right, there it is. That's the equation of the line. So if I were to draw this parabola, right? If I were to graph it, it opens down because there's a negative here. All right. If we were to go to an x value of 1, it would spit out the y value of 3. And if I were to graph this line right here, that line would just pass right through that point, like that. Now, this is a very loose graph, okay, but that's the idea of what we just did. First thing we did in part A was found the slope of this line. The second thing we did was actually nail down exactly where it is. All right, so number 2, by the way, skip part C because it asks you to graph. I mean, you could go and graph those answers and check, but you're not required to have a graphing calculator, so. Number 2, same exact thing, different function. So see how you do with that. All right, let's look at number 3. For 3, find an equation of the tangent line to the curve at the given point. Wow, this is so similar. Number 3 is so similar to what we just did. I think I'm going to do 4. So I'm letting you do 2 and 3. I'm going to do 4. Because the algebra in number 4 is just a little bit different. X cubed minus 3x plus 1 at the point 2, 3. So let's keep in mind that this is A, this is f of A. So I'm going to first start out by saying, forget this, I'm going to call this f of x. And they are not telling me which formula to use, so it's up to me. I know that the slope of the tangent line is either limit as x goes to a of f of x minus f of a over x minus a, or I can also say it's the limit as h goes to 0 of f of a plus h minus f of a over h. My choice, my choice. So I don't care. I don't care. Flip a coin. All right, I'll flip a coin. I don't have a coin. I'll flip a, the only thing I've got. Here, this. Heads, tails. So heads we do this, tails we do this. All right, here we go. Tails it is. All right, so we're gonna do this one right here. So this equals the limit as h goes to 0. All right, what's f of a plus h? Remember, a is 2, so this becomes f of 2 plus h minus f of a, which is f of 2, all over h. Now that's equal to the limit as h goes to 0. I have to plug 2 plus h into this function everywhere I see an x. That's going to be ugly. 2 plus h cubed minus 3 times 2 plus h plus 1. That's just this minus what's f of 2? Well, we already said right here, this is f of 2, right? 2, a is 2, so f of 2 is 3. This is just 3. And then all over h. And unfortunately, I have to expand all of this out, which means I have to take 2 plus h and I have to cube it. So maybe I'll do that up here. So 2 plus h times 2 plus h. There's some shortcut formulas for something like this, but I'm just going to do it by hand. I'm going to do those two together first. So I get 4 plus 2h, so plus 4h, plus h squared. And then I multiply 2 through these, and then I multiply h through. So when I do 2 through there, I get 8 plus 8h plus 2h squared plus here to here 4h plus here to here 4h squared plus h cubed. And that's just going to be this top left corner. And why don't I combine like terms? So h cubed, let's see, h squared, 4h squared and 2h squared is 6h squared. 8h and 4h is 12h. And then I have plus 8. All right, so this equals the limit as h goes to 0 of this piece right here, which is all of this junk, h cubed plus 6h squared plus 12h plus 8. I'm going to run out of room. Then distribute minus 6 minus 3h. And then plus 1 minus 3, that's the same as minus 2. All of this over h. Now if we've done everything right, we should be able to get this h to cancel. And I think you can see that 8 minus 6 minus 2 is 0. And everything else you have left there has an h in it. So let me come over here. This is the limit as h goes to 0 of h cubed plus 6h squared. And then I think we have, what's that, 9 h's all over h. Factor an h out of the top. Cancel. And we're at the final step. We're going to take the limit as h goes to 0 of h squared plus 6h plus 9. And if h goes to 0, that's gone, that's gone. All you get is 9. So the slope of the tangent line should be 9. I'm just checking it real quick mentally. Yeah, all right. So now, that's just the slope. We need the equation of the tangent line. So I'm going to use this again. And I can replace y1 with 3. My slope, which is 9. Then x minus x1, which is 2. I can now distribute the 9 through. And now I can add 3 to both sides. Y equals 9x minus 15. There we go. So that's the equation of the line that would intersect this graph at this point and would be tangent to that curve. All right, that was nice. Let's do 5. 5 is just root x. Doesn't look so bad, does it? And they give you the point. 1, 1. I'm going to draw a little quick picture. Here's the point. We're trying to find the equation of the line that runs tangent to this curve at that point. So remember that a is 1 and f of a is also 1, right? But you may as well call that f of 1, right? So these go together and then these go together. So I know that the slope of the tangent line will be equal to the limit. Let me use the first one since I used the other one for the last problem. All right, so we'll do that one. I'm going to replace all my a's with 1. And I'm going to replace f of x with whatever f of x is. So root x minus f of 1, which we already know is 1 itself, over x minus 1. And if you check, if you try and plug 1 in, we'll get 0, 0, which is bad. So we need to do something here. And remember the conjugate, because I see a radical there. Come in with the conjugate, root x plus 1 on top, root x plus 1 on the bottom. Let's see what happens. Limit, x approaches 1. So when we do this times this, we just get x. The middles don't matter. Right, this and this cancel, and then we have -1 and +1. That multiplies to be -1 over the bottom, x minus 1. And I told you in class, don't multiply these out, leave them. And you can see here we get canceling there. So we get limit, x goes to 1. We have a 1 on top. We still have root x plus 1 on the bottom. And if you plug in 1 now, root 1 is 1, 1 plus 1 is 2, so this is just 1/2. We're not done. Now we need to use y minus y1 equals m times x minus x1. So y minus 1 equals 1/2 times x minus 1. So just replacing the m with this, replacing y1 with 1 and x1 with 1. Distribute the 1/2 through. And then add 1 to both sides. Y equals 1/2 x, and then when you put those together, you get plus 1/2 again. There's the equation. All right, let's look at number 6. Oh yeah, by the way, that was number 5. I had written 4 up there. Number 6, y equals 2x plus 1 over x plus 2. And the point that we're given is 1, 1. All right, maybe we should use this one again. Again, doesn't matter. Sometimes the algebra is better one way. So I'll try this one. I'm replacing a with 1. I think I'll move over just a little bit. This is equal to limit x approaches 1. Okay, let me try and go a little faster. What's f of x? Well, f of x, that's it right there. 2x plus 1 over x plus 2. What's f of a? Well, f of a is f of 1. And what's f of 1? It's this value right there, which is just minus 1. Then over x minus a is x minus 1. So here we have a complex fraction, so we're going to try and get a common denominator, which means I'm going to look at this 1 as being a 1 over 1, and then I'm going to multiply x plus 2 bottom and x plus 2 on the top, and then combine those two together. So when I do this, I'll have 2x plus 1 minus whatever this is. So I have to subtract each term, right? So minus x minus 2 all over x minus 1. This is the limit as x approaches 1. Oh, this is real nice. We get 2x minus x, that's x. 1 take away 2 is minus 1. And man, these just go away right away. This is just 1. So the limit is 1. And that's the slope of our tangent line. So now we say y minus y1 equals m times x minus x1. So y minus, let's see, y1 is 1 equals the slope, which is 1, times x minus x1, which is also 1. So this is just y minus 1 equals x minus 1. And if we add 1 to both sides, you get y equals x. Interesting. Interesting. All right. Now, number 7 is where we are going to start to try and generalize. All right. This is kind of leading us into the next section. If we have y equals 3 plus 4x squared minus 2x cubed. 3 plus 4x squared minus 2x cubed. We're trying to find the slope of the tangent line at the point where x equals a. So they don't tell us a point specifically. They're trying to get us to get a general answer. Say, okay, for any point a, what's the slope of the tangent line? So a in this problem is actually equal to just a. And I'm going to use, let's see, Let's go with the h to 0 this time. Let's try this one on this. All right, so notice I'm not going to be able to replace a with anything. I'm just going to have to leave it. So what I'll do first is I will replace into my function a plus h. So everywhere I see an x, I replace it with a plus h. I have 3 plus 4 times a plus h squared minus 2 times a plus h cubed. Nasty. Okay, minus, that's this, f of a. That means come in here and replace this with a and this with a, but subtract the entire quantity. So I'm going to do this in parentheses. It's that function up there, 3 plus 4, but replace the x with a, so a squared, minus 2, and then replace the x with a cubed. All of this over h. And I have a lot of work to do. Limit h goes to 0. All right, 3. Okay, that's not bad. 3 plus, all right, 4 times this. 4 times, now what is this squared? I'm assuming you could do that on your own. Okay, so that's what you would get if you square that. Minus 2 times whatever this is cubed. So again, I'm going to assume you could do a plus h times a plus h times a plus h. You would get a cubed plus 3ah, sorry, a squared h, plus 3ah squared plus h cubed. That's what you would get if you actually cube that. And then minus, I'll distribute the minus through, minus 3 minus 4a squared plus 2a cubed. All of this over h. That looks pretty ugly. Actually, it's quite beautiful. All right, keep it going. Limit h goes to 0. All right, 3 plus 4a squared plus 8ah plus 4h squared. So just distribute the 4 through here. Then distribute a negative 2 through. Minus 2a cubed, that's this, minus 6a squared h, here to here, minus 6ah squared, here to here, minus 2h cubed, and we still have minus 3 minus 4a squared plus 2a cubed, this entire thing over h. And I am hoping that the h will cancel. Well, I'm counting on it actually. So a lot of things are going to have to cancel. Let's see, 3 and 3 are gone. 4a squared and 4a squared are gone. 2a cubed, negative 2a cubed and 2a cubed. And everything else in here has an h. So I'm okay with that. Limit h goes to 0. All right. All right, okay, I'll write it. 8ah plus 4h squared minus 6a squared h minus 6ah squared minus 2h cubed all over h. Now, since everything in the numerator has an h in it, I will factor an h out. So I'm going to do this without having to rewrite the whole thing. Here I pull an h out. When I pull an h out, that h goes away. This h squared becomes an h. This h goes away. And this h squared becomes an h. And this h cubed becomes an h squared. Like that. And then those h's will go away. And at this point, I can let all my h's go to 0. So this doesn't have an h in it, so it's going to stay. This goes to 0, that's gone. This does not have an h in it, so it's going to stay. This has an h in it, so it's gone. This has an h in it, it's gone. And so the only thing left is 8a minus 6a squared. Now this is the slope of the tangent line at x equals a. Now the value of this is, if somebody gives me a value of a now and wanted to know the slope of the tangent line, I wouldn't have to go through the process again and again and again. I've done it once in general, so if someone gives me a now, I've got the slope. So I think that's what the next question asks, or the next part of the question. Part B, it says, find the equation of the tangent line at the points 1, 5, and 2, 3. So let's talk about this at 1, 5. 1, 5, and then at 2, 3. So at 1, 5, let's first determine what the slope of the tangent line is. The slope of the tangent line is going to be equal to, remember this now, I'm replacing the a with 1, right? Because that's the x-coordinate. If I just replace the a with 1, we get 8. Let's see, 1 squared is 1 minus 6, we get 2. I know what the slope is without having to do all the work. And then from that, I can go to the y minus y1, which is 5, equals the slope 2 times x minus x1. And then from there, you can get y by itself. But essentially, we're there. We have the equation of the tangent line. And then if we want to do it again for a different point, like this one, a is 2, then we know that the slope of the tangent line is equal to, well, we just plug 2 in here. So 2 times 8 is 16, minus, let's see, 2 squared is 4. 6 times 4 is 24, so subtract 24. And that gives us negative 8. And then the equation of the tangent line is y minus 3 equals negative 8 times x minus 2. So just using that point slope formula again for each of those. The only thing that's really changed, well, a lot's changed. The slope is different, of course, and then your y1, your x1 are different. So 2 different equations for tangent lines because we are at 2 different points on the curve. But us working through this in general was ugly, but the benefit to it is that now we can start getting equations of tangent lines very quickly without having to grind out the actual slope every single time. Do it once, and don't have to do it again. All right, number 11. Don't you hate that when you look at your watch and then you realize that you didn't even look at your watch, so you look at your watch again? All right, number 11, it's a word problem. If a ball is thrown into the air with a velocity of 40 feet per second, its height in feet after t seconds is given by this equation. So they're telling us that a ball that's thrown into the air will be at this height, whatever we get, when we plug in t for time, which is in seconds. So after a certain number of seconds, this tells us how high the ball is off the ground. So at 0 seconds, the height is 0 feet. But if you plug in 1 second, 1 here, then you'll get what, 24 feet. That's how high the ball would be. Find the velocity when t is 2. So this is what we had talked about earlier in the class, that we're trying to find the instantaneous velocity, which is actually equal to the slope of that tangent line. So what we'll do is, I'm going to write down, we want the velocity at t equals 2. In other words, what they want is the slope of the tangent line at t equals 2. Which means that I can rewrite this as a function first. I'm going to call it f of t, not f of x. Notice that our variable is t. And then I can use either one of the definitions to come up with the slope of the tangent line. I'm going to use this one, limit, as h goes to 0. So this slope of the tangent line will be this. F of a plus h minus f of a over h. Now be careful, if you were going to use the other one, you would do limit as t approaches a, not x, of f of t minus f of a over t minus a. You'd have to replace all your x's with t's because that's our variable in the problem. But I don't need to worry about that because I'm doing it this way. So for us, when they say t is 2, it's kind of like them saying x is 2. This is our a. Right, so let me come over here. Remember, I'm not using that one. This is limit h goes to 0. All right, f of a is 2. 2 plus h minus f of 2 over h. Which is, this is just confusing me up here. Let's get it out of here. All right, we need to plug 2 plus h into this function, which means we replace that t and that t with 2 plus h. So that's enough room. Limit h goes to 0. 40 times 2 plus h minus 16 times 2 plus h squared. That's what we get when we plug 2 plus h into this function. Now I subtract from that f of 2. So let me plug 2 in here, all right, and see what we get. I'm just going to write it up here. 40 times 2 is 80, minus 2 squared is 4. 16 times 4, 64. Right, 16 times 4, yeah, 64. And then when you subtract these two, you get 16. So I get 16 all over h, which is equal to the limit, let me pass the 40 through, 80 plus 40h, okay, that's this and this, minus 16 times this thing squared, which is 4 plus 4h plus h squared. You do that on your own. Minus 16, all of this over h. Equals limit as h goes to 0 of 80 plus 40h. Distribute through here, minus 64, minus 64h, minus 16h squared, then minus 16, then all over h. And now cancellation hopefully happens. 80, take away 64, that leaves you 16, and then you take away 16, it's gone. Everything else here has an h in it. In fact, I can put these two together, right, and get negative 24h. So all I'm left with on top is negative 24h minus 16h squared. And I'm going to realize that I can factor an h out of the top. I'm going to do that now. H comes out. I'll be left with, I pulled an h from that, so negative 24. Pulled an h from that, so negative 16h. Then all over h. And there it goes. That's what I wanted. And now when you let h go to 0, that goes away. All you're left with is negative 24. Now, that's our slope of our tangent line, but how do I interpret that as a velocity? Well, remember, the height of this object was measured in feet, and the time was measured in seconds. So this right here, this instantaneous velocity, will be written as negative 24 feet per second. So at exactly 2 seconds, this object is traveling at a speed of negative 24 feet per second. Very nice. What was that, 11? Okay. 15. Man, there's still a lot more to do in this, I think. Let me see how much more I have. Whew, got a ways to go. Let me just try and finish up this page 81, and I'll come back and do more video later. So for 15, we have, for the function g whose graph is given, arrange the following numbers in increasing order and explain. Ooh, this one's going to be hard because I've got to draw this graph perfectly. Oof. All right, let me try this. Negative 1, 1, 2, 3, 4. So I know this point's here. It kind of goes up like this and goes up and then goes down like that. Okay, down at the bottom here. It looks like it bottoms out there just about here. Comes up and then goes up like this. That, okay, looks like it does that. And then they give you some values. 0, g prime of -2, g prime of 0, g prime of 2, and g prime of 4. All right, so this notation means the prime means the derivative means the slope of the tangent line. So I don't have a ruler in here. I'll just have to make up my own ruler. Here's my ruler. So let me start out. Oh yeah, and 0 is just the number 0. So let's look at the derivative at -2. So I come over here to -2. I take a look at this, and I try and imagine what the slope of the tangent line would be there. So it looks like the slope of the tangent line would be something like, here's the tangent line, right? And it looks to me like that slope is approximately 1, right? Because a diagonal line has a slope of 1, flat line slope of 2, line like this is a negative slope. A line like this would have a steeper slope, so it would be like maybe the slope of that's 2 or 3 or 10. Can't go vertical though, because vertical means that you have an undefined slope. So I'm going to say that this slope is approximately 1. See, this is where I don't know if my drawing is going to be good enough. All right, what about at 0? The derivative at 0. So I go to 0, and the slope of the tangent line there is going to have to pitch negative like this. Like that, I don't know. Looks close to -1. Yeah, approximately -1. Now how about at 2? Man, it's really hard to tell. This one right here. I tried to draw the best I could. I think that the slope here at 2, right here, I think that this line, from me looking at the picture, I think this line isn't as steep as this one. I think this one is steeper. So this one is kind of tilted down a little more. So I would say that this is approximately, I'm again estimating 0.8. It's not quite as steep as this one. And then g prime of 4 looks like, if I go to 4 and come up here, the slope of that line is also positive, but it's even less steep than this one. So I don't know, maybe it's like approximately 0.4. I'm guesstimating here, and that's what they want you to do. So I just need to arrange these in order of what? Arrange these by increasing order. So from smallest to largest. So the smallest I would have would be this one. So I'm going to say this is my first one. That's the smallest, -1. And then 0, so this would be 2. And then 0.4, this would be 3. Then 0.8 would be 4. And then 1 would be 5. So those values are just arranged in order from smallest to largest now. The key to this problem is just to get you to be able to look at a graph and kind of have an idea of like at which points you have steeper slopes than other points. All right. Number 17. If an equation of a tangent line to a curve y equals f of x at the point where a is 2 is this, find f of 2 and f prime of 2. Okay, that's confusing. 17. Say if the equation of the tangent line to a curve, so you have some curve, they're not telling you what it is. And they're telling you that the equation of the tangent line, so the equation of the tangent line at a equals 2 is this, y equals 4x, y equals 4x minus 5. They want you to find where is that? F of 2 and f prime of 2. All right. So we have some curve out here, all right? 1, 2. Okay, we have some curve. I don't know what it's doing. But what I do know is that at 2, come here, the equation of this line right here is y equals 4x minus 5. Well, I can answer the second one right off the bat, this one. I know that this is 4. Now the reason why is because by saying f prime of 2, you're saying what's the slope of this tangent line at 2? Well, we already know the slope of the tangent line from the equation y equals mx plus b, which is what we're looking at here, that this number in front's the slope. So I know that the slope of the tangent line is 4. Now to find f of 2, that's a little more confusing, but you can think of it this way. This point right here, right, on this line, lives both on the curve and on our tangent line. So if I plug 2 into the black curve, the y value should be the same as if I plug 2 into the red curve. So plug in 2 for x, and this is 8 minus 5, which is 3. So the y coordinate here should be 3. So f of 2 is 3. That's it. 19. Sketch a curve that satisfies these conditions. All right. 19. So here are the conditions we have. F of 0, 0. F prime of 0 is 3. F prime of 1 is 0. F prime of 2 is negative 1. Let me start with that first condition because that's just algebra. F of 0 is 0. That point is there. The slope of the tangent line, the derivative, the slope of the tangent line at 0 is 3. So 3, oops, I jumped away from that like it was fire. Slope of 3, right, this slope of 0, slope of 1 is like this, 3 is like pitched up pretty steep. So I know that my curve when it comes through here is going to have a pretty steep tangent line. So when I draw it, you know, maybe I need to do something like this, okay? And then the derivative at 1 is 0. So if I go out here to 1, when I get there, wherever the point is, and it doesn't tell me where the point is, the slope at that needs to be 0, which needs it to be flat. So I'm just going to come up here and flatten it out like this. All right? And then the derivative at 2 is negative 1. So here's 2. I don't know where the point is, but I know when I get to it, the slope of the tangent line needs to be negative 2, which is pretty steep. So it's got to go something like, maybe like that. So I don't know, just go like this, like that. That's a function. F of 0, 0, the slope of the tangent line there is 3, pretty steep. I should have drawn that a little steeper. Maybe something like that. And then at 1, the slope of the tangent line is 0. And then at 2, the slope of the tangent line is negative 1. Man, I don't have time to finish all these. All right, that's a good place to stop. All right, we'll be picking up where we left off here in, I believe it's 2-1. All right, so we stopped, I believe at number 19. I was going to do number 21 next. So number 21 says if we have a function f of x equals 3x squared minus x cubed. Find f prime of 1, and then find the equation of the tangent line to the curve y equals 3x squared minus x cubed at the point 1, 2. So they kind of confuse you by writing out, first saying f of x is this, and then say find the equation of the tangent line to the curve y equals this. It's the same curve. So really, we want to know the equation of the tangent line to this curve at this point. So we first need to figure out what the derivative at 1 is, because that's equivalent to the slope of the tangent line at that point. So this will be equal to limit, I'm going to use the h one, h goes to 0, f of a plus h minus f of a all over h. And for us in this problem, a is 1. So we get f of 1 plus h minus f of 1 all over h. And now we get to plug 1 plus h into the function wherever we see an x. So here and here. So we'll have 3 times 1 plus h, that quantity squared, minus 1 plus h cubed. And then minus, right here, f of 1. So let's plug 1 in real quick and see what we get. We should get 2 because that's the point on the curve, but I'll just verify. 1 in here, that gives me 3. 1 here, 1 cubed is 1. 3 minus 1 is 2. So yeah, we get 2 there. So this is 2 all over h. And now I get to go and simplify this. So this will be equal to, I really think I prefer to work here, right in the middle. So we have equals limit, h goes to 0. All right, I'm going to expand this out, 1 plus h times 1 plus h. So I have 3 times 1 plus 2h plus h squared. That's this. Minus, and then 1 plus h cubed. If you did that, you get 1 plus 3h plus 3h squared plus h cubed. And then we still have minus 2, and all of this over h. I'll distribute the 3 through, I'll distribute the negative sign through, and I'll clean it up. So limit, h goes to 0, 3 plus 6h plus 3h squared minus 1 minus 3h minus 3h squared minus h cubed minus 2, and then all of that over h. All right, and I'm hoping that everything's going to go away except stuff that has h's in the numerator. So if we do 3, take away 1, take away 2, that's gone. And everything else has an h. So equals limit, h goes to 0. Let's see how many h's I have. 6 h's, take away 3 h's. That leaves me with 3h. Okay, I've done that now. H squared, 3h squared minus 3h squared. Oh, those are actually gone. And then I have minus h cubed. All of that over h. Factor an h out of the numerator. So h, and then 3 minus h squared. And then over h. Cancel. Let h go to 0, and that goes away. We get just 3. So the slope of the tangent line to this curve at the point 1, 2 is 3. So now to come up with the equation of the tangent line, I use y minus y1 equals m times x minus x1. So y minus 2 equals m, which is 3, times x minus 1. And then y minus 2 equals 3x minus 3. And add 2 to both sides, y equals 3x plus minus 1. There we go. All right, that's it for number 21. 23. Very similar, but the algebra in that one's kind of ugly, so I think I'll work through it. Number 23. They define a function capital F of x to be equal to 5x over 1 plus x squared. And they want to know what f prime of 2 is, capital F prime of 2 is. So what's the slope of the tangent line at 2? And then they want to know the equation of the tangent line at the point 2, 2. So the slope of the tangent line at 2 is going to be f prime of 2, which is by definition limit h goes to 0, and then it's going to be capital F of 2 plus h, that's a plus h, minus capital F of a, which is f of 2, all over h. That's just our definition, which is limit as h goes to 0 of, let's plug 2 plus h in for x here and here. So that's going to be rather complicated. 5, and then I'm plugging in 2 plus h over 1 plus 2 plus h squared. Then subtract from that f of 2, and if I plug 2 in here, I get 10, and then 4, and then plus 1 is 5, so 10 divided by 5 is 2, and that matches up with this. Most likely on the test, I won't give you the point. You're going to have to come up with that point yourself, but you can see all I'm doing is plugging 2 into this. So minus 2, and then that entire thing divided by h. All right, this one's weird. I have a complex fraction, right? So what I'm going to try and do is get a common denominator. So I think I'll rewrite this 2 as 2 over 1. So my common denominator is going to be this. So I need that to be over here on top and bottom. So I have to multiply, unfortunately, by that entire nasty thing. So I'm going to multiply this by 1 plus 2 plus h squared on the bottom, and then 1 plus 2 plus h squared on the top. And then they'll have the same denominators. And then I can put them together. So my next line will be the limit as h goes to 0 of this numerator minus that numerator. So 5 times 2 plus h, it's this, minus 2 times all that, 1 plus 2 plus h squared, all of that divided by my common denominator, which is that common denominator, 1 plus 2 plus h squared, but then all of that divided by h. And I get to clean up that numerator. So I'm going to distribute 5 through. I'll distribute negative 2 through, but I've got to figure out what that is first. So maybe I'll do that right up here. So we get 10 plus 5h minus 2, and I'm gonna do this first. 1 plus, when I square this, I should get 4 plus 4h plus h squared. Then all of this divided by my common denominator. Then all of that divided by h. Now I can pass this through. Also notice these two together, that's a 5. So shorten up my life of working on this a little bit by just going 10 plus 5h. Okay, distribute. Negative 2 times 5 is negative 10. Hey, look, those 10s are going to cancel. Negative 2 times that, that's negative 8h. Negative 2 times that, that's negative h squared. And that's all over the common denominator. Don't forget this thing. Then all of that divided by h. And I'm hoping everything's going to cancel except h's up here. So 10, 10, gone. And then these two can come together. That gives me a negative 3h. And I'll have minus h squared still. All right, so I have negative 3h minus h squared over my common denominator, all of that over h. And notice on the numerator, these each have h, so I'm going to factor an h out. And I think for this one, I'll do it, since it's a complex fraction, I'll do that h on the bottom as h over 1. And on my next line, I'll write h factored out, negative 3 minus h over my common denominator. And then this h over 1, I'm going to flip it up as 1 over h. And these h's will cancel. And now I let h go to 0. So if that goes to 0, it's gone. I just have negative 3. And then I have 1 plus, now if this is 0, this is just a 2. 2 squared is 4. So 4 plus 1 is 5. So negative 3/5 is my slope of my tangent line. So now the equation, y minus y1 equals m, negative 3/5, times x minus x1. And then you could solve for y if you wanted to. All right. Let's go to 25. So 25. We give you this function 3x squared minus 4x plus 1. And they ask you to find f prime of a. So we want the slope of the tangent line at a, but they're not going to tell us what a is, which means we need to get a general answer. And so I'm going to have to use the definition f prime of a equals, now I haven't used the other one in a while. Let me use the other one. Limit as x approaches a of f of x minus f of a over x minus a. So let me just try this one. So this equals limit as x approaches a of f of x, which is that function with x plugged in, which is just itself, minus, now be careful, f of a is that function with a plugged in, but we're subtracting it. So subtract 3a squared minus 4a plus 1, and all of that over x minus a. And now I will distribute that negative through. 3x squared minus 4x plus 1 minus 3a squared plus 12a minus 1 all over x minus a. Now, because this is a different formula, I don't want the h to cancel. I actually want x minus a, the entire factor, to cancel. I do notice that these 1's go away. And everything else I have there, I may be able to do something with. So let me try this. Limit x approaches a. Yeah, this is going to be a little messy. I need an x minus a to cancel, so let me get this x squared and a squared next to each other. 3x squared minus 3a squared. And then I still have minus 4x plus 12a all over x minus a. And notice that on this first two terms, we're almost going to do like a grouping here. On the first two terms, I can factor out a 3. So I have 3, then I have x squared minus a squared. That look familiar? Then over here, I'm going to factor out a negative 4 from those. Negative 4, and I'm left with x minus a. And that's nice, because it looks like I'm getting closer to being able to cancel the x minus a, except I would need an x minus a here and here to be able to cancel it all 3 places. So I noticed that's a difference of squares. So this becomes 3x plus a times x minus a minus 4 times x minus a all over x minus a. And now at this point, I can cancel this x minus a because it appears here, here, and here. So you could imagine just pulling an x minus a out of the top and then it would cancel, but I'm just going to go, and that leaves me with limit as x approaches a of 3 times x plus a, that's this piece, minus 4. And now if I let x turn into an a, this turns into an a plus a is 2a. 2a times 3 is 6a minus 4. So 6a minus 4. That's it. You should try 26 on your own. Well, you know what? I think what I'd like to do is I'd like to do this problem with the other formula just to illustrate the difference. If I do the other formula instead, then this would have been f of a plus h minus f of a all over h. So let's see if this one would have been any easier. If I plug a plus h into the function, I get 3 times a plus h squared minus 4 times a plus h plus 1. But then I have minus f of a minus, and then f of a would be 3a squared minus 4a plus 1. But then all of that just over h. And now limit h goes to 0. All right, if you expanded this out, you could, do that, and then you distribute a 3 through. You would get 3a squared plus 6ah plus 3h squared. That would be this. Now distribute a negative 4 through, negative 4a minus 4h, and then plus 1. And then distribute your negative through, negative 3a squared plus 12a minus 1. All of that over h. Yeah, I think this way's a lot easier. Here's gone, 1's gone. Yes, yeah, that looks good. Everything that's left has an h. Oh wait, 12a. Hold on a second. Missed something up here. Plus 1, 3a. I'm missing something obvious here. Oh, right here. Sorry, when I did this 12, I saw the 3 and brought it over. It was negative 1, so that just plus 4a. Okay, that's good. These go away. All right, now, this is going to be equal to the limit as h goes to 0 of, okay, since everything has an h in it, right, everything that's left has an h in it, I'm just going to pull an h out now. And that would have left me with just 6a here, and then plus just 3h, and then here just minus 4, and then all over h. The h's cancel, and now when you let h go to 0, that goes away, and you're left with 6a minus 4. Same answer. I like that way a little better. And actually, this is probably going to be the way that we do most of our limits from here on out. We'll focus a lot more on this formula. All right. Next problem. (27). Let me see. 27 looks a lot like something I've done before, but yeah, I'm gonna stick with it. I'm gonna do it. 27. F of t equals 2t plus 1 over t plus 3. I want to know f prime of a, which is the limit as h goes to 0 of f of a plus h minus f of a all over h, which is limit h goes to 0. Okay, plug a plus h in here, right there and right there. So we get 2 times a plus h plus 1 over a plus h plus 3. Now minus, now just plug a in. You get 2a plus 1 over a plus 3. All of this over h. And I have a very complex fraction here. I need a common denominator, which should consist of both this piece and this piece. So I'm going to multiply the top and bottom of this one by a plus h plus 3. And I'm going to multiply the top and bottom of this one. I'm going to be kind of out of room here, but by a plus 3 over a plus 3. And keep in mind, this has to be in parentheses right there because it's like two pieces. Same with this, parentheses right there. Oh, nasty. So here's where I'm at. Limit, h goes to 0. Now I'm just going to write out what we have. We have a plus 3 times 2 times a plus h plus 1 minus, because of the minus, this times this, so 2a plus 1 times a plus h plus 3. All of this over my common denominator, which is a plus h plus 3 times a plus 3. All of this over h. And if that doesn't look ugly, well, you're not alive, I guess. All right. All right, how do you want to go about multiplying this out? My goodness. We have so many different options, algebra, so we can do so many different things. How about I do this? Just to start, this right here, this little 2, let me pass that through. That would become a 2a, and this would become plus 2h. So change that to 2a plus 2h. There we go. Now I'm going to multiply a binomial times a trinomial, so I'm going to go a through first. After I'm done with that, I'll pass the 3 through. I should get a total of 6 things here. Limit, h goes to 0. Okay, a times 2a is 2a squared. A times 2h is 2ah. A times 1 is just a. Plus 3 times 2a is 6a. 3 times 2h is 6h. 3 times 1 is 3. All right, that's it for that first one. Then I have to do this one. Here, 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 here. And whatever I get, I'm going to subtract. So every single one of these, I'm going to change the signs. So 2a times a is 2a squared, but I'm subtracting it. Then 2a times h is 2ah, but I'm subtracting it. And then 2a times 3 is 6a, but I'm subtracting it. Now the 1. 1 through here is a, but I'm subtracting it. 1 through here is h, but I'm subtracting it. And then negative 3. Whew. All of that over the common denominator. All of that over h. And I'm really hoping that everything goes away upstairs except for the h, an h somewhere in all things. So that 2a squared better cancel because it doesn't have an h in it. So here, 2ah minus 2ah, good. A, that better go away. Here we go, a. 3, I just noticed that, 3, negative 3. 6a, negative 6a, and positive 6a. Man, there's a lot of stuff going away. Man, the only thing left on top is 6h and minus h, which is just 5h. (5h) on top, over the common denominator. All of this over h, but I'm going to rewrite that. H over 1, I'm going to flip it up and say times 1 over h. And that h cancel. Once they cancel, I let h go to 0. When I let h go to 0, just that goes away. And so everything else is still there. You have the 5 up top. You have just a plus 3 times another a plus 3. So this is just 5 over a plus 3 squared. There it is. Whew. All right. I like it. What is that from? Where have I heard that from? I like it. So I've already had some students make some comments about the fact that I talk to myself in here. You know who you are. But I'm sitting in this room by myself with calculus problems. It's hard not to go crazy, I guess. All right, here we go. X to the negative 2. Now remember, this is just 1 over x squared. Okay, let's not make this more complicated than it has to be. Negative exponent, drop it down. All right, well, if I want to know the derivative at a, we just do limit, h goes to 0, f of a plus h. I'm going to try not to write that. F of a plus h just means I'm going to plug a plus h into that. 1 over a plus h squared minus f of a, which is just a into that, and all of that over h. You get a common denominator here. I'm not going to work this one all the way through. Common denominator, you have to multiply top and bottom here by a plus h squared over a plus h squared. And then over here, a squared, and then go through and do your thing. That one's going to work out pretty clean. At the end, you should get negative 2 over a cubed at the end. $29. Yeah, this will be my last one. Although I really like 30. 29. One minus 2x. So the derivative at a is the limit as h goes to 0 of f of a plus h. So I plug a plus h in that. Be careful. 1 minus 2 in parentheses a plus h. Then minus, I plug a into that. So f of a is square root of 1 minus 2a. Then all over h. And immediately you should be thinking conjugate, because you see 2 radicals there separated by subtraction. We can come in here and introduce root 1 minus 2 times a plus h plus root 1 minus 2a, and I do the same thing on the bottom. And remember, when you do the one on the bottom, you're not going to multiply it through here by this h. You're not going to try and force it in there. You're just going to leave it out there by itself. But this one on top, you will have to FOIL it out. But we know because it's a conjugate that the middle terms will go away. So we just have to worry about the outside. So what is this times itself? Well, the root and the root go away. You're just left with 1 minus 2 parentheses a plus h. And then when you do the middle ones, they go away. The last ones, this times this, the root goes away, but positive times negative is negative. So you're going to have negative of whatever was under there, 1 minus 2a. And you have to have that in parentheses. Over h times, and I'm not multiplying this, all this junk, square root 1 minus 2 times a plus h plus square root of 1 minus 2a. And I know for a fact the numerator should clean up. All right. I'm just going to write above this what this is. When I distribute through, I get 1 minus 2a minus 2h, and then when I distribute here, I get plus 1 plus 2a. And so cleaning this up, let's see, just the 2a's go away? Oh no, that was a minus 1. Apologize. minus 1 plus, so minus, and that means those 1's go away also. Even better. All I'm left with is negative 2h on top, and then the bottom is h times this thing, square root 1 minus 2 times a plus h plus root 1 minus 2a. And these h's cancel. And now I can let h go to 0. And when I do, I still have a negative 1 on top. And on the bottom, if h is 0, then this is just a. So this becomes 1 minus 2a under a root. And over here, plus another one of those 1 minus 2a's. Now notice it's addition, not multiplication, so I can't put those together like just make the root go away. It's just like you have an apple plus an apple, you got 2 apples. So you should get negative 1 over 2 square roots of 1 minus 2a. There it is. All right, number 38. They want you to read that, then they want you to go to this graph, and they just want you to estimate. They have a curve, and then they have a tangent line they draw for you. They want you to estimate the slope of that tangent line. So just try, the best you can to figure out what the rise over run is on that, and that's an approximation of the slope of the tangent. And then on 47, it's the same sort of thing. Those I'll just leave to you. I think that's good enough. All right, that's it for 2-1.